everyone, thank you for joining us today, and in today's lesson we're going to be looking at circles and tangents. We're obviously talking about analytical geometry. So if you are watching and you're in grade 12, you've done quite a few years now of analytical geometry and you probably have quite a good idea of what analytical geometry is. But let's just recap, remind you of what analytical geometry is, and we're also going to, in today's lesson, look at properties of circles specifically, equations of circles centered at A, B, and equations of tangents drawn to circles. So those are the main topics for today. But first we're going to remind ourselves what analytical geometry is all about, or analytic geometry. And you obviously, for this section of work, as for any other section in grade 12, you need to have all of the knowledge that you've gained so far from your previous grades. So you need to know different formulae in that for analytical geometry. You know, obviously you're going to get your formula sheet, but you need to know when and how to use those formulae. Okay, so what is analytic geometry? It's also known as coordinate geometry, and the reason for that is it's geometry that's drawn on a Cartesian plane. So it's with all your points and lines and your axes of symmetries and all of that. So it's the study of geometry using a coordinate system. The only one that you know so far is the XY coordinate system. Its discovery is credited to two French mathematicians, and those two guys are Descartes and Fermat. All right. Now recall the following from your previous work. You have also done work on this previously, and you've revised this at school and so on, so it shouldn't really be too much for you to recall without having your formula sheet. But the distance formula is to work out the distance between any 2 points. So if we want to work out a distance, let's call it PQ, that distance will be the square root of the difference between the two x values squared plus the difference between the two y values squared. All right, so you'll have two coordinates, one x1, y1, x2, y2, if you want to say x2, y2, or xy, and then you'll find the distance between those 2 points using that formula. Your midpoint formula helps you to find the midpoint of any line segment. So the midpoint of a line, let's say PQ again, is the sum of the two x coordinates. So x1 plus x2 divided by 2, that gives you the x coordinate, and then it's the sum of the two y coordinates divided by 2. All right, gradients or slopes. We know the gradient is given by the change in y over the change in x, and obviously here we're just talking about straight lines. Now the angle of inclination, this is something that you've heard of before as well. The angle of inclination is how you work that out. You first need to work out the gradient of your straight line. The gradient of a straight line is then equal to the tangent of the angle formed between the line and the positive direction of the x-axis. Okay, so this is what that means. So I've got my y-axis, I've got my x-axis. The angle of inclination, if I were to draw a line, straight line, cutting through the x and y axis as shown, then the angle of inclination, to find that, we know that the gradient of this line is equal to the tangent of the angle formed between the line and the positive x-axis. All right, so the gradient is equal to the tangent of that angle. All right, to find the equation of the straight line, we know that it's y is equal to mx plus c. We can also use y minus y1 is equal to m times x minus x1. Remember, to find the equation of a straight line, you need to have the y-intercept if you're using y is equal to mx plus c, and you need to have the gradient. All right, but if you're going to use the other formula, y minus y1 is equal to m times x minus x1, you need to have the gradient and you need to have one other point. So often what you may need to do is you may need to use your other point to help you work out your y-intercept if you're using the first form of the equation that I gave you. All right, now let's talk about the key for today's lesson, which is circles. Okay. Most of you know an ordinary, if I just say to you circle, you can see it in your head, you know what it is. It's centered at the circle at the origin on your axis with the circle center being 0, 0. You've all seen those kind of circles, right? So as I'm going to show you on your screen now in a drawing. So it's a circle where you've been given that the origin, which is the origin of your Cartesian plane, which is the point 0, 0, you know that that kind of a circle is the set of all points, and this certainly holds for all circles as well. A circle, what is a circle? It's a set of all points that are an equal distance. This equal distance we call the radius from the center of the circle. Now the distance from the center of the circle to any point on the circle is the radius. Okay, so let's put a circle in here so that it makes sense as we refer to these points. Okay, just a little one. All right, so what we're saying is the distance from the center of the circle, all right, and I'm not getting the center quite correct, but that's fine, it's just a rough sketch. So the distance from the center of the circle to any point on the circle circumference is called the radius. The distance around the whole of the circle, so as we go around the circle, that is called the circumference, and we also say that's called the distance around the circle, that's called the perimeter. The diameter of the circle is any line passing through the center of the circle which connects 2 points on the circle. So 2 points drawn on the circle and passing through the center, that line that connects those 2 points is called the diameter. All right. It is also the name given to the maximum distance between any 2 points on the circle. So all of this stuff is really just revision for you guys. You know this. I don't have to state it, but I just want to remind you of what we're going to be referring to and terms we might use as we go through the lesson. So you need to be familiar with this. Okay, now say we have any point P, x, y, with coordinates x, y, and that's a point on the circle with a center O, and that's at the origin 0, 0. Okay, so the coordinates at the origin of your coordinate system is 0, 0. The radius is r. Then we can work out that the equation of the circle is given by x squared plus y squared is equal to r squared. So guys, this diagram shows you what we're saying here. We can use the distance formula to work out what the equation of the circle is. So basically, we're saying, using this triangle, you can see from Pythagoras, we get that x squared plus y squared is equal to r squared. And using the distance formula, that's how we can determine what the equation of the circle is. We're not going to go into detail of how to determine the defining equation for a circle centered at 0, 0. It's not important for exam purposes, but you can show it using the distance formula. All right, now let's talk about equations of circles that are not centered at the origin. Okay, so you can actually move the circle around to any point that could become the center. So instead of it being 0, 0, it could be 2, 4, minus 2, 4. It can move to any quadrant or any point. Okay, so now let's have a look at this. If you consider a circle in the Cartesian plane that's centered at the point AB, so we said those coordinates can be anything, right? It's got a radius of r units. And if P is any point on the circumference of the circle, so it has coordinates x, y, we can then use the distance formula to calculate the distance between the 2 points, so the distance CP, that is. Okay, so using the distance formula, you can work out that distance. So let's have a go at that and let's see what we get. So we know using the distance formula, PC, that distance, is going to be the square root of x minus a. Okay, so that's my x coordinates at P minus my x coordinates at C, plus y minus b. Okay, so that's y coordinates at P minus y coordinates at C. So this is going to give me PC. Okay, well, let's just leave it at that point. We don't want to simplify that any further. So we've got PC is equal to the square root of x minus a squared plus y minus b squared. But if I wanted to now get rid of the square root, what do? I square both sides, right? All right, so I'll get PC squared is equal to x minus a squared plus y minus b squared. Okay, but we know that the length PC is actually the radius, r units, of the circle. So therefore I can replace PC with r squared. And this gives me the defining equation for a circle centered at any point A, B. Even with 0, 0, this would work, okay, guys? Because if A was 0 and B was 0, then this would just become x squared plus y squared. Okay, so it would work with any coordinates there. All right, so that's the defining equation of any circle centered at AB, where AB are any 2 points. So we have a formal statement here. If P, X, Y is a point in a circle centered AB as your coordinates with a radius r, then the equation of the circle is x minus a squared plus y minus b squared is equal to r squared. And obviously you've seen how we can work out that defining equation, and we can prove to ourselves that that is indeed the equation for any circle. All right, okay. So what we're going to do next is we're going to have a look at a question where we're going to use this circle center AB to help us to work out the length of the radius and the center of a circle. All right, so we've got to actually take the equation that we've been given and write it in standard form. Okay, so if you have a look at your screen, we are determining the center and the length of the radius for that circle. Okay, so I want you to try this. Remember, the easiest way to do this is going to be to write it in the form of x minus a squared plus y minus b squared is equal to r squared, where a and b are the coordinates of the center of the circle, and r, if you take the square root of r squared, that is obviously going to give you the radius of the circle. Okay, so I'm going to give you guys 3 minutes to have a look at this and to take this question down. Let's see how far you get. Okay guys, so I suspect that you need a little bit more time to do this one, right? So we had to find the center of the circle and also the length of the radius. I'm going to give you a few more minutes to do that. We'll be nice to you. We'll take a quick break and we'll come back and do this question together after this. Welcome back everyone. So a reminder of what we're doing in today's lesson. Today we're looking at analytical geometry, and specifically we're looking at the circles and tangents. We're looking at the equation of circles, and we're also going to later on look at the equation of a tangent drawn to a circle. So before the break I asked you to determine the center of the circle and the length of the radius given an expression or an equation, okay? And the way you had to do this in order to get this equation into standard form, which is x minus a squared plus y minus b squared is equal to r squared, where a and b are the centers of your circle, your x and y coordinates. Well, the way to do that was to complete the square. Okay, so let's go through that together. All right, and I like to think that this is easy marks. You may disagree, but hopefully not. Okay, so you've got your equation expression there. The first thing you want to do, guys, is you want to try and simplify this. We don't like working with things that are going to complicate the expression any more than it has to be. So what you really need to do is you want to get the coefficient of the x squared, you want to get that to be 1. So what you do is you divide through by the coefficient of x squared, which is 3. All right, so if we do that, we're going to get x squared plus 2x plus y squared minus 4y minus 11 is equal to 0. Okay, so I've divided all of the coefficients by 3, and that's made my equation look a lot simpler. So at this point, we now need to complete the square. Okay, so in order to get this equation in our standard form, we need to complete the square. You'll notice that you have two variables. We've got x and y. Okay, so while it might look a little bit tricky to work with these because, well, it's two variables, what do? Well, we're going to do each one separately. So we'll complete the square for the x part of the equation, complete the square for the y part of the equation, and then we'll simplify it all together. Okay, so the first step, we've already done that. We've divided through by the coefficient of x squared. Now, we need to take the constant term, that's the term without any variable. So in this case, it's your 11. You take it over to the right-hand side. Okay, so I'm going to move it over to the right-hand side. Remember, your sign is going to change from minus 11 to positive 11. Okay. Now we complete the square. So your rules for completing the square that you learned in grade 11, they're still exactly the same. So to complete the square with x squared plus 2x, what do? I'm going to say bring down x squared plus 2x. And then I have to say plus a half of the coefficient of the b term squared. Okay, so what have I done there? I've said, well, the coefficient of the 2x is 2, all right? So therefore, I'm going to say a half of the 2, and I squared that. Remember, this is an equation, so if I do it to one side, I have to do that on the other side as well. So I'm going to say plus a half times 2 squared. So basically what I'm doing, guys, is I'm using this little section here. I'm completing the square for the x part of the equation, and then I need to do the same thing for the y part of the equation. So we complete the square with that. All right? Okay. So we say, well, bring down y squared minus 4y. And then we add a half of the coefficient of the b term. So a half of the coefficient. When I'm saying b term, remember this is quadratic expression. So we've got ax squared plus bx plus c. And the b term is the coefficient of the x. All right? So a half of minus 4, which we know is minus 2. But anyway, we'll put that down. So a half of minus 4 all squared. It's an equation, so what I do to one side, I must do to the other. So I have to add a half of minus 4 all squared. All right, Now think about this. Why do we need to do this in this form? Why do we have to complete the square? And it seems like this is where a lot of learners think, well, this is really tricky and I'm getting confused. If you use the rules that you already know from grade 11 for completing the square, we don't change those rules in any way. We just add to that, okay? So the reason we're completing the square here, as you've done many times before, is to factorize, okay? So once I've got this expression or this equation in this form that you have on your screen, you can factorize the individual pieces of this equation. All right, so I can factorize the expression that has the x in it, and I can factorize the y part. All right, so to factorize the left-hand side, I'm going to say it's the square root of x squared, which is just x, plus you always use the sign of your b term, so it's going to be plus, and then it's just whatever is the answer inside your bracket. That's going to be the next term to factorize this trinomial. Of course, you could times this out, guys. You could do this, x squared plus 2x plus 4, and then you could factorize that, yes, but that's going to take longer, so this is a quicker way to do it. So it's the square root of x squared, which is x. We take the sign of the middle term, so it's going to be a plus, and then whatever's inside the bracket is going to be the number that I'm going to add in. So a half times 2 is just 1. All right? Sorry, this should be a 1 here, not a 4. All right, so a half times 2 is 1. And then we say that trinomial factorized is going to be x plus 1 squared. Okay. So that's a quicker way to factorize instead of timesing everything out. Plus we do the same on the other side, so it's square root of y squared is y. Take the sign of your middle term, so it's going to be negative. And negative what? Negative whatever you've worked out in there. So your answer here, all right, ignoring your sign of course, so a half times minus 4 is going to be minus 2, but I've already got the minus in there, so a half times 4 is just 2. And that's what I put in the bracket, so it's y minus 2 all squared is the factorization of that trinomial. Once again, you could work out the trinomial and factorize this the long way. All right, so you could say, okay, well, 2 squared, that's going to give me 4, and you could then factorize that the long way. All right, but we're not doing that. And then on the other side, I've got 11 plus 1 squared, which is just going to give me 1, plus a half times minus 4, we said that's minus 2. Minus 2 squared is just 4. So we've got 11 plus 1 plus 4, which is going to give me 16. So now we're happy because now this looks like the general form of an equation with center AB. Okay, so if you go through what your choices were here, so you had A, B, C, D, and we see that in B, right? We've got that the center is the same because your center here, remember, if you work it out, your center is going to be the coordinate, the x coordinate is going to be whatever's inside your bracket with the opposite sign. So if you're thinking about it like x plus 1 is equal to 0, then the x coordinate of the center would be minus 1. So the x coordinate of the center is going to be minus 1, the y coordinate is going to be 2. All right, so we see that in B, we have that the center is minus 1, 2. We see that in A, the center is also minus 1, 2. The difference comes in this. Is the radius 4 or is the radius 16? And hopefully none of you fell for that trick, okay? Because r squared is not your radius. It's the length of the radius squared. So if you want to find the radius, you need to take the square root of whatever your answer is here on the right-hand side. So we've got r squared, as you can see, is equal to 16. So therefore, your radius will be the square root of 16, which is going to give you 4. Obviously, minus 4 is not applicable because a length will never be negative. So therefore, your answer here would be A, where we have the center as minus 1, 2, and the radius is 4 units. Okay, and I hope that all of you got that one. Okay. Now, we also mentioned that today we're going to be talking about tangents and finding the equation of a tangent that was drawn to a circle. Remember that a tangent is just a straight line. So really what we're talking about is finding the equation of a straight line. And you already know from previous years, to find the equation of the straight line, you need a point or 2 points, or you need a point and the gradient. Okay, so depending on what you have, you can work out the equation of a straight line using your gradient intercept method or the other method that I showed you earlier. So let's talk about tangents and the equation of a tangent to a circle. So if you forgot, a tangent is a straight line that touches the circle at only one place. Okay, so in your diagram, you can see that AB will be a tangent to circle C because AB touches the circle at one point D with coordinates x, y. All right, some important things that you need to note about a tangent. The radius of the circle, so in this case CD, will be perpendicular to the tangent at the point of contact. So the radius of a circle is always going to be at 90 degrees to the tangent line. Now that is very important because we know something really interesting about the products of gradients of perpendicular lines. Hey, we know that the product of the gradient of the radius and the gradient of the tangent line must be equal to -1. And that comes from the fact that if two lines are perpendicular, so this is for perpendicular lines, the product of their gradients will always be -1. So if one of our lines is M1 and the other one, the gradient is M2, so one has gradient M1, the other one has gradient M2, well, the product of those two gradients will be -1. So what that means and how that's going to be helpful for us is if we can find out the gradient of either one of those lines, either the tangent or the radius, then we can work out the gradient of the other line. All right. Okay, guys, I'm going to give you some time now to have a look at another question. Take this question down, see how far you get to it with it. We will come back and do it together. We're going to take a break after you have a look at this question, so I'll give you quite a bit of time to do this one. All right. So I'm going to give you another 3 minutes now to take this one down and to start working on it. Okay, everyone, so as I promised, we're going to give you a bit more time with this question, and that time comes now. During this break, have a look, carry on with this, and we will go through this together after this. Welcome back, everyone. So in today's lesson, just a reminder, we are looking at circles. We're looking at finding the equation of a circle with center AB, and we're also looking at finding the equation of a tangent drawn to the circle. Okay, so before the break, I asked you to do a question for me. Let's now go through the question together, and hopefully we all end up at the same answer. Okay, all right, so we were given the point P, which is 2 and minus 4, and it's on the circle x minus 4 squared plus y plus 5 squared is equal to 5. You are then asked to find the equation of the tangent at the point P. So let's have a little drawing so that we can see what's going on. And obviously it's just a rough sketch. I'm not even going to put it on a Cartesian plane. It's just so that we have an idea of what they're asking us to do. So now that they've given me the equation in standard form, x minus 4 squared plus y plus 5 squared is equal to 5, I can identify a few things. The center of the circle is going to be the point 4 minus 5. So it's basically the values that are inside the bracket once the square has been completed in your equation. It's the values inside the brackets with the opposite signs. My radius is going to be the square root of 5. Okay, so you can see that this equation, we can just read off the values once your equation is in standard form. Okay, so I've got that my center is the point 4 minus 5. And they also tell me that there's a point 2 minus 4 that is somewhere on the circle. So we're not going to put it exactly where it is. As I said, this is not on a Cartesian plane, but let's say, okay, well, P can't be there because it's got to be to the left of 4, so let's say it's somewhere here. So P is the point 2 minus 4. Okay, and we know that it's a tangent, so therefore it means it touches the circle at just one point. So if I draw a line in, this is what's going to happen. We've got that line touching at this point, P. Okay. They asked you, they said, well, find the equation of this tangent. And now we need to draw on some important things that we've already learned about tangents drawn to circles. We saw that, firstly, the tangent is just a straight line. So I know the defining equation, y is equal to mx plus c, all right? And we also learned that when the tangent meets the circle at that point of contact, that tangent is going to be perpendicular to the radius. And that was an important point because that means if I've got the 2 points, I can use those 2 points to work out the gradient of what this tangent will be. Okay, so if you look back at your drawing now, we've got the point 4 and minus 5, and we know that the radius is perpendicular to the tangent, right? So therefore, we know that that angle between the two lines is going to be 90 degrees. Okay, so we've set up all the information that we've got. We've drawn it on our diagram. Let's answer the question. So the first thing we're going to do is work out the gradient of the straight line. So I know that the gradient is going to be y2 minus y1 over x2 minus x1. Okay, the straight line I'm talking about here is the tangent. So I first work out the gradient of the radius, and the gradient of the radius is going to be equal to, so it's the change in y, and remember it's important the order that you take it. So if you start at the center with the y, you need to start with the center when you're doing change in x. So it's going to be minus 5 minus minus 4 all over 4 minus 2. Okay, so that's going to give me minus 5 plus 4, which is minus 1, over 2. Now, guys, that's the gradient of your radius. Therefore, the gradient of my tangent, we know, times by the gradient of my radius is equal to -1. So therefore I can say, well, if the gradient of the tangent is -1/2, if the gradient of the radius is -1/2, then the gradient of the tangent is going to be -1 divided by -1/2. So -1 divided by -1/2. So you see I've set up a little equation there, and we'll get that the gradient of the tangent is 2. Obviously, there's a quicker way to do it. If we've got the gradient of the radius is -1/2, to find the gradient of the line that's perpendicular, which is the tangent, you simply invert the fraction, so it becomes 2/1, and you change the sign. So from a minus, it becomes a positive, and that will be the answer. So it's basically the reciprocal of -1/2 with the opposite sign, and the product will then give me -1. So now we've got the gradient of the tangent, which is 2. We now need to find the equation. So I'm going to use this expression to find my equation of the tangent. When we use this, yes, we know that the gradient is 2, but we also need an x value and a y value, a coordinate that lies on the straight line that we wish to find the equation of, and we do have that. We've got that P is the point 2 minus 4, so therefore I can say y, so P was the point 2 minus 4, okay, so this is my x1, and that's my y1. Those are my coordinates. So therefore I'm going to say y minus y1, which is -4, is equal to 2 times x minus x1, which was 2. All right, so we'll get 2x minus 4. I'm just distributing into the bracket. And then we get y minus times minus is a plus, so I get y plus 4 is equal to 2x minus 4. Therefore, y will be equal to 2x minus 8. Okay, how did I get minus 8? Bring the 4 over to the right-hand side. It becomes -4, -4, -4 gives me -8. So therefore, we've got the equation of this tangent line. Now, when I look at the equation of this tangent line, I realize that my drawing is incorrect because firstly, the gradient is positive. So therefore, to make an accurate drawing, yes, we would need to plot these points on a Cartesian plane. But remember, the sketch is it's a sketch. It's just to give you a basic idea of what it is you need to do. All right. So really what we were looking at here, if I turn my diagram around, my straight line, my tangent around, you're looking at the tangent being a line with a positive inclination. So it's going to look more like this line. Okay, and then obviously our radius as well, we'll turn it around. So that's how your diagram is more likely to look. But remember, what we're worried about here is just getting a rough sketch down so that we can put a few points down to help us interpret the question. You are not going to be marked on the sketch. This sketch is just for your own purposes. Okay. All right, guys, let's have a look at another question. All right, once again, dealing with circles and tangents. And remember, the important thing for you here and where you will get better with this section is by firstly knowing how to complete the square in order to get the defining equation for your circle, but also understanding how you can find the equation of the tangent given information about the circle and about the radius of the circle. Okay, so as always, it's going to be lots and lots of practice, but there's a few key things that you need to remember when you look at this section. Okay, so I want to give you a chance to have a look at another question. This is question 3, and here I'm going to give you 3 minutes to take the question down, and then we will do it together. Okay, everyone, so that was more than enough time to get the question down, and hopefully you're all going to get to where I get to with this question in terms of getting the answers correctly. But more importantly than that, remember, it's not about the answers, it's about the logic and the method that you use to get there. Let's go through this very quickly. We don't have much time, so let's do this quickly. We've given that there's a circle. We've got x minus 1 squared plus y minus 7 squared is equal to 10. Okay? Determine the values of x if the point x4 lies on the circle, and then you also have to find the gradient of the tangent to the circle at the point 2, 4. Now, from the equation that was given to you, you can see that the center of the circle will be the point 1, 7. Okay, we know that the radius of the circle will be the square root of 10. Okay, because this is given to you in your standard form. Now, for the first part of the question, when they want you to determine the value of x, what they tell you is that the point x4 lies on the circle. Now, guys, you know that if a point lies somewhere on the circle, any point, doesn't matter what point it is, so we're going to say it's the point x4. If the point lies on the circle, then the distance from that point to the center of the circle will always be the same, because what is that point, what is that called, that measurement? That distance is called your radius. So if a point lies on the circle, then that length is always going to be equal to the length of the radius. So the distance between the center and that point is also going to be equal to the length of the radius. So that's what we're going to use to help us work out the value of x. So let's do it quickly. We're going to say x minus 1 squared, which is my distance from the point to the center of the circle, plus y minus 7 squared is equal to r squared. R is root 10, so r squared will be 10. Okay, we'll simplify this quickly. So we get x minus 1 squared plus, we know the value for y. Y has the value of 4, right? So I get plus 4 minus 7 squared is equal to 10. So 4 minus 7 giving me 3. 3 squared is going to give me 9. So I get x minus squared is equal to, I'm going to take the 9 over, so I'm doing this quite quickly. 4 minus 7 is minus 3. Minus 3 squared is 9. Take it over to the right-hand side. 10 minus 9 is going to give me 1. And then I'm going to square root both sides to get rid of the square. And I'll get x minus 1 is equal to plus or minus the square root of 1, which is plus or minus 1. Therefore, x is going to be equal to either 1 plus 1, which is 2, or 1 minus 1, which is 0. So those are the two values for x. All right. Now they tell you if find the gradient of the tangent to the circle at the point 2, 4. Okay, so they tell you that x actually has the value of 2. So if I want the gradient of the tangent, so if I were to draw a line there, I want the gradient of that. I need to find the gradient of the radius and then find the negative inverse, which will give me the gradient of the tangent. So first we work out the gradient of the radius. So it's going to be using the coordinates 1, 7 and 2, 4. So 1, 7 is the center, 2, 4 is a point on the circle. So the gradient of the radius will be 4 minus 7 all over 2 minus 1. So that's going to give me 4 minus 7 is minus 3. Minus 3 over 1 is just minus 3. So therefore, the gradient of the tangent will be the negative inverse of that. So therefore, the gradient of the tangent is going to be 1 over 3 with the opposite sign, so positive 1 over 3. All right, so hopefully all of you got to that same point, but remember the important thing is the method. So if your method was correct and you made a few careless mistakes, that's okay. The important thing is that you understand the concept and how to get to work out the gradient of the tangent. Okay. We're now going to quickly recap what we've done in today's lesson. So you saw that if a point P, x, y is a point in a circle with center 0, 0, then the radius, and the radius is r, then the equation of the circle is just x squared plus y squared is r squared. If your point is x, y, but now your center is a B, and your radius is still r, then the equation is x minus a squared plus y minus b squared is equal to r squared. We saw that a tangent is a straight line that touches the circle at only one point, and the radius of the circle is perpendicular to the tangent at the point of contact. Okay, everyone, that's it for today's lesson. I hope that you really have a much better understanding now of how to work with circles and tangents. Until next time, I'm Natasha. Cheers.